Hello and welcome back. In this part we are going to create the last of these stiffness, and then we will add these two mounting plates and the corresponding stiffness. Okay, so we are going to reuse an existing part to create our last stiffness. So again, with the copy option, and this time we will rotate 45 degrees, 45, and okay. Now we have to move this component so that we have this 9 millimeters offset. 9 millimeters is the distance between this reference XY plane and the bottom face of this stiffener. So we should check to see what is the current distance, and we will use this minimum distance. Okay, so we will select the XY plane and then the bottom face, and now you can see in this report that the distance in the Z direction is minus 12 millimeters. This means that we will have to move 12 millimeters first, then add an additional 9 millimeters, so a total of 21 millimeters. Okay, we will close this, and then using the steering wheel, move this 12 millimeter. Okay, now before we do anything else, go ahead, right click, more, replace part with copy, and S6, then save, and we make sure that the component is grounded also, and that's it. We are ready to move on. But actually no, because I just realized that I forgot to move the additional 9 millimeters, so I should have moved 21 instead of 12. So I will just add 9 millimeters again, and this time I will check to see if it is the correct value from this face to this face, and I have the 9 millimeters offset. Okay, so now we can dive in and edit the part in place, show all the reference geometry, and Control Q to show assembly geometry as well. We will first edit the first interpart copy. Select this metal component. Now we select this face and this small face. Okay, that's it. Now the intersection is okay, and we can go ahead and edit as we already did plenty of time before, the protrusion. So we'll remove the constraint, Control Q, then this will go like that. I will add a horizontal vertical constraint to these two endpoints. I want to be sure that I am on a circular or close to circular portion of this curve, because as you can see, this face is distorted on this area, and I want to be sure that I am the farthest away possible from this area. So again, normal 2, Control Q, and now I will add a dimension from this to this endpoint, so something like this. And now I will connect this point to a point like this, and just an endpoint to there, and we are okay. Now this value should be 490, and as you can see here, the profile is a little bit different. So we have a 45-degree angles there, and now instead of having this round up to this line, we have a flat portion, then an angle face. Okay, so we have to add a line like this and another one tangent to this one. We'll use the trim tool to remove this portion and this one and this one and this one, then the connect tool to connect this to this. Now a dimension from this one to this, and the value should be 620 plus 545, 620 plus 545, and we'll make sure that this midpoint is, or maybe we should add an angle between these two, and this will be 50 degree, and we should make the middle point of this line align to the origin and vertically. And to finish, we will add a connect constraint between this endpoint and the intersection curve. And now the sketch is fully defined. We will keep this value driven by the assembly variable, and now we can close and finish the protrusion. Okay, Ctrl Q. Just wanted to be sure that the intersection curve will be on this top face, and it is okay. Now we edit the cutout, normal 2. As usual, remove this one and we include this and this. Now we are going to add a small chamfer to clear the welt at this location. So we use the trim tool to remove the non-necessary portion. Oops. So trim tool, this one, and then dimension, oops, angle, we'll use 22,5, and the dimension will be 16. Okay, and now to finish, let's see, we hide this one, and with the connect tool connect these two endpoints. Okay, I don't know why these curves stay underdefined, but I think maybe it is because we should have a tangency at this endpoint, but I don't really know how to explain it, because this is an include and this one an include also, so we should not have to do that. It should already be fully defined. Okay, so we are going to let that slide and close sketch and finish, and this will be all for the stiffness. Now we are going to go for the mounting plate, and for the first mounting plate we will just add a new component. So we'll go into the edit in place mode and right click to accept. We will rename it M1 as mounting plate 1. Okay, and save. Okay, Ctrl Q to show assembly geometry, and we will go to the home tab, and insert enter part copy, so we'll use this face, and next we will create our protrusion from the XY plane. Ctrl Q and normal 2. Okay, so we want to draw something like a simple rectangle, and I made a guesstimation of the size of this plate, because as you will notice, or you are probably already noticed, there is no indication of these distances. Okay, so this is my estimation. Okay, so we'll draw a rectangle which will extend up to the reference surface we just created. Okay, so just have to draw a rectangle, so something like this. Then we had horizontal vertical constraint from the midpoint to the origin. Then we'll add this 400 distance, and the distance between these to the origin 1265. Am I okay? Yes. And we will guesstimate this dimension as something like 450. A bit quite enough. Now we can close the sketch, and we should have a thickness of, let's see. Okay, so the total thickness is 40 millimeters, and there is a 5 millimeters distance between our reference plane to the bottom face of the mounting plate. So you will have a unsymmetrical extent, 5 millimeters in this direction and 35 millimeters in the other direction. So we will choose this non-symmetric extent, and in this direction we will enter 35, and we'll click to place the 35 millimeter extent, and then we'll move to the other direction, and we will add a distance of 5 millimeter. Okay, now so it will be this direction, and now we have our protrusion created. Okay, right click to finish, then cancel, Ctrl Q to show assembly components, and you can see how the stiffener is positioned in relation to the mounting plate. Okay, now we want to remove this unnecessary portion of the part, and to do that we are going to use the substract tool. Okay, so the substract tool is located in this solids panel, and it is underneath the add body tool. Okay, so if you click on the small black triangle, you can access the substract tool from this menu. Okay, so we select subtract, and the target body is this protrusion, so we select the protrusion and right click to accept, and now we have to select the tool body. The tool body is this enter part copy surface, and now you can see this side of the part is removed. Obviously this is not what we want, so we have to reverse the direction of the subtract. To do that, just click on the arrow, and you can see how the subtracted side is flipped, and now we have the correct final geometry. We can now right click and finish and cancel. Now Ctrl Q, and we have to remove the material where the stiffener will be located. So we'll use the cut tool and we'll make sure that we are sketching on the ZX plane. Then normal to fit, and we will include this geometry, add a line from there, and we will also add a contour in this location for the small recess we have on the bottom of the mounting plate. Okay, so we will include this and this, and now using the trim tool we will remove the unnecessary areas, so like that. And now we can add dimension. So first we will add this 90 millimeters. Okay, so we'll bring this back inside and this like that, and we'll add the 5 millimeters distance we have here. Then this angle should be 45 degrees, and we will guesstimate a dimension for this one. Let's see. Okay, so again select the line and the origin, and what is large enough, so 900. Oops 900. Okay, will be okay. And now we can close sketch and return. We make sure that we are cutting through all and symmetrically, and that's it. Now we just need to add these contour holes, and we should have 2 of these, space 290, and the diameter should be 30 for the holes, and the contour should have 55 millimeters diameter, and the depth of the contour is, in my estimation, close to 5 millimeters. Okay, so hole tool, and I will use this top face as the coincident plane. Okay, so I'll select the face, then normal to, and options, simple contour. So the hole is 30, the contour diameter 55, contour depth 5, the hole is through hole, and that's it. Now okay, and you will place the 2 holes, and make sure that they are aligned horizontally, excuse me, and this dimension 290, dimension from these holes to the origin. We will not enter no value because we will use an equation, so this dimension should be this one divided by 2. Okay, and now we have to add the distance between this axis and the holes, and the value should be, let's see, 1265 minus 40, or we should just use the 40 in this case. 40. Now we can close and return, and the last step is just to indicate the sides, and that's it. Okay, cancel. Now Ctrl Q, and you can see how the parts are positioned relative to each other. Now close and return to the assembly. Okay, now we will add the rip or the stiffness to this plate and this sheet metal component. And let's see, so you have to show these 16, 17 components. So 16, 17, then we will save the configuration, and now we will add a new component, so stiffener, and we will name it stiffener 7, then save. Now we need to bring in some reference geometry, so interpart copy, we will select this component, and from there this face, then this component and this face. Okay, now we are going to go ahead and create our protrusion, and we want it from a parallel face, since the two stiffeners are 180 degrees apart. This means that we have a 90 millimeters distance between the external face and the reference vertical plane. Okay, so we should have this as the reference plane, and we will enter 90, and next normal 2, then Control Q, and we make sure we have the pierce edge locate active. We select this endpoint, then we will make sure we click on this edge of the mounting plate. Now we'll move something like that, then a vertical line, and we'll close to this endpoint. Okay, now this angle is 15 degrees, and the distance between the two lines is 130. Okay, so a dimension, angular dimension between these two, 50, and make sure that we connect this endpoint to this one. And if we try to use the smart dimension to create the distance between these two lines, we can, because the two lines are not parallel. We should make them parallel first, and let's try again. We'll select this line first and then this line. As you can see, we cannot create directly the distance between the two. Even if you use the shift key, we can't. Okay, the way to do that is to use this distance between. You make sure that you have this use dimension axis active, and now we will click on this button to define the axis of the dimension, or how the dimension will be aligned. So we select this line, and now you can click to define the origin element, so this line, and now the measurement element, this second line. As you can see, we can now create the distance, and we change the value to 130. Now to fully define the sketch, all we need is a dimension between this line and the origin, and we will input, let's say, 900. Okay, now we can close and define our protrusion. Okay, we make sure that the non-symmetrical extent option is no longer available, so we just click, and now we will define the thickness to 12 millimeters, and that's it. Okay, and Control Q to hide, and now we have to remove the non-necessary portion so that the stiffener, the vertical stiffener, is correctly positioned on these two parts. Okay, to do so, we are going to make sure that these two surfaces form a single face, and again, surfacing, stitch tool, select this one also, then right click, and we have this error message. This can happen because the two surfaces do not properly intersect. So to fix that, what we can do is to make sure we extend each of these surfaces, and then we will trim them. So we will select this first one and extend like that. So we make this option finite extent active. We extend this first like this, then right click to accept. Now we make sure we select the second one, we extend also. Now we'll use the intersect tool, then we have to select the two bodies and accept. And now we have to select the region to remove. Okay, what we want to remove is this portion and this one. Okay, and now we can right click to accept. Okay, we have to remove this one also. So again, we'll edit the intersect and select this step, and we will remove this part also. I forgot something else. Okay, maybe this one too. And right click to accept again, and that's it. Okay, now we can go ahead and try to perform the subtract. So here, subtract target body, and for the tool body, as you can see, we cannot select the two surfaces at the same time. Okay, so we have to add a stitch operation first. So this one and this one to form a single body, then cancel. And now we can go ahead and subtract using this as the target body and the tool body. This one is reverse the side, and that's it. Then cancel. I don't know if anybody in his right mind will cut this exact shape. In the real manufacturing world, it will be something just straight, but for this tutorial we will leave it just like this because it is to demonstrate the feature. Okay, now close and return to the assembly, and we are going to stop this part of the tutorial here. In the next part, we will add the bottom stiffness, and we will mirror these two vertical stiffness to complete this side of the spiral casing.